We all know that the greenhouse effect is the process by which radiation from a planet's atmosphere warms the planet's surface to a temperature above which is abnormal what it would be without this atmosphere. Okay, let's see about it. Radiatively active gases is the other name of greenhouse gases. In a planet's atmosphere, radiate energy in all directions. Part of this radiation is directed towards the surface, warming it. The intensity of the downward radiation, that is, the strength of the greenhouse effect, will depend on the atmosphere's temperature and the amount of greenhouse gases that the atmosphere contains. Earth's natural greenhouse gas effect is critical to supporting life and initially was a precursor to life moving out of the ocean into land. Human activities, however, mainly the burning of fossil fuels and clear cutting of forests, have accelerated the greenhouse effect and caused global warming. We all know the global warming is also a major crisis for our human and nature. The planet Venus experienced runaway greenhouse gas effect resulting in an atmosphere which is 96% carbon dioxide with surface atmospheric pressure roughly the same as found 900 meter, that is 3000 feet underwater on Earth. Venus may have had water oceans, but they would have boiled off as the mean surface temperature rose to 735 Kelvin. The term greenhouse effect continues to see use in scientific circles and the media despite being a slight misnomer, as an atmosphere reduces radioactive heat loss while a greenhouse blocks convective heat loss. The result, however, is an increase in temperature in both cases. So, let's take a deep descriptive note about the greenhouse gas. The greenhouse gas which is the earth receives energy from the sun in the form of ultraviolet, visible and near infrared radiation. About 26% of the incoming solar energy is reflected to space by the atmosphere and clouds. 19% is absorbed by the atmosphere and clouds. Most of the remaining energy is absorbed at the surface of earth. Because the Earth's surface is colder than the Sun, it radiates at wavelengths that are much longer than the wavelengths that were absorbed. Most of this thermal radiation is absorbed by the atmosphere and warms it. The atmosphere will also gains heat by sensible and latent heat fluxes from the surfaces. The atmosphere radiates energy both upwards and downwards. The part radiated downwards is absorbed by the surface of the Earth. So some of the details about the greenhouse model is simplification. In reality, atmosphere near the Earth's surface is largely opaque to thermal radiation and most heat loss from the surface is by convection. Within the region where radioactive effects are more important, the description given by the idealized greenhouse model becomes realistic. Greenhouse gases including most diatomic gases with two different atoms such as carbon monoxide and carbon oxide, and all gases with three atoms are able to absorb and emit infrared radiation. Some of the greenhouse gases are water vapor 36 to 70%, carbon dioxide 9 to 26%, methane 4 to 9%, ozone 3 to 7%. It is not possible to assign a specific percentage to each of the gas because the absorption and emission bands of the gases overlap. Clouds also absorb and emit infrared radiation and thus affect the radioactive properties of the atmosphere. So this plays a major role in climatic change, and the real greenhouse is built of any material that passes sunlight, usually glass or plastic. The sun warms the ground and the contents inside just like the outside, and these warm the air. So some of the other bodies than Earth affected by greenhouse effect is Venus, particularly large for reasons. It is nearer to the sun than Earth by about 30%. Its very dense atmosphere consists mainly of carbon dioxide. Venus experienced a runaway greenhouse in the past, and we expect that Earth will be in about 2 billion years so as solar luminosity increases. So we all conclude that greenhouse is one of the major crises for human and nature. Let's take a look on history of the existence of the greenhouse effect. The argument and the evidence were further strengthened by 1827 and 1838. John Tyndall was the first to measure the infrared absorption and emission of various gases and vapors. So the description about the greenhouse gas effect. Earth receives energy from the sun in the form of ultraviolet, visible and near infrared radiation.